Well, hello there, AniCod here, and this time I'm doing an idiot-proof guide to electric. I tried to make one before, it was pretty popular, but it still confused quite a lot of people. So here I go again with a 2021 version. It starts off really simple, it gets gradually harder and harder as we go through the video. I'm hoping with how simple I make it, you should be able to keep up all the way to the end. It all depends on your level of ability. Let me know if you made it to the end in the comments down below, or at least if you learned something new throughout the video. So here we go. Now let's start with getting a basic ceiling light to work. All we have to do with this is place it on the roof, but that's not all. These things need power. For this we've got a few options. I'm going to take you through the batteries. Now these store power, they can be recharged and they can output power, all of which I will explain now. Batteries come in three sizes: small, medium and large. So how do we get power from the batteries to the light? Well, for this we need a wire tool. You can craft them for two high quality, and once you have one you can wire up as many circuits as you like. You don't need to keep having to craft loads of these. Now when you look at a battery with the wire tool, you will see this little confusing list that makes you feel like understanding it will enable you to hack into the Pentagon or something, but it's much more simple than that. You've got the charge left at the top, which is in time. This will go up or down if the battery is in use or charging. Again, we'll cover this a little bit later on. Active usage, for example, the ceiling light will use 2 power, so when we wire this up it will show 2 here. If we have 2 lights then it'll show 4, and so on. Maximum output for a small battery is 10, which means if we keep using lights you can only wire up a maximum of 5 before the battery becomes overloaded and blows up in a sea of sparks and virgin sauce. I'm only joking, everything just turns off. Also you'll have capacity. Now this is complicated, and because this is a beginner guide I'm not going to go into this too much and confuse you before we even start, but basically RWM stands for rust watt minutes. It's made up for this game and it just shows you the rate of discharge compared to the input, kind of. If you're unsure, just use the charge left at the top. It does the same thing but in time, what we all understand. So what's the difference between the batteries then? Well, the main thing is that the maximum output is different. For a small battery it's 10, medium battery it's 50, and large battery it's 100. All batteries have an output and an input, and obviously you'll need the output going into the item you want to receive power. So let's give it a whirl, girl. You can't wire anything up backwards because it won't let you, so don't worry too much about this. When you're running a line you'll notice some numbers. This is the length of wire left before you have to make sure it's connected up. Now unless you're part of a big group in a huge base, this isn't going to be a problem. Now simply link the power out of the battery into the power in of the light, and there you go, let there be light. Bit of an issue with this one, you'll see that the active usage is now showing 2 because of the light connected to it, but the timer is going down because we're using the power and we have no way of stopping it until the timer hits 0 and the battery's dead, or we disconnect the wire. This means we're going to need a way to control it. So what can we do? Well, first of all let's disconnect it and we can put a switch in between, and this can be our first control. This will enable us to turn the light on and off, so we can only use power during the night and we can keep the light off during the day and save power. All we have to do is place it on the wall. As you can see it's just a bog standard switch. There's 4 points you can connect it on this, but we're just going to concentrate on the bottom and the top for now, not the side ones. Now the power out from the battery goes into the bottom of the power in. If you try the other way around it won't let you, and the power out at the top of the switch will go into the light. So basically the switch is just sitting in between the battery and the light, and now you can control the power simply by pressing the switch on and off. Granted, there's another issue with this, and that's the fact the battery is still going down when you've got the light turned on, so we need to find a way to charge the battery. Now there's 3 ways to do it, 2 of which I'll cover. The third way is a generator, but we're not going to go into that in this video. The 2 that I am going to cover uses green energy because bears and stuff. So for this we've got solar panels and we've got wind turbines. To place a solar panel, simply put it in your inventory and place it down, and it's as simple as that. There is a few tips I can give you, and one is to make sure you place it outside and in the right direction to get the most bang for your buck. You can use the compass at the top of your screen. The sun rises in the east and sets in the west, so you want to put one of these panels either facing north or facing south. Ideally, you could do it one north and then one south back to back, and this will give you the most light throughout the day. Now there's only one output from a solar panel, and you can simply just put this straight into your battery in order to charge it. If you are lucky enough to have two, then you can actually link them together. For this example, I'm going to show you a turbine, and then I'm going to link the turbine and the solar panel together. Before you can do this, you do need a special tool, but I'll show you that in a minute. So when you place the turbine down, you can see that they're absolutely huge. They do output a massive 150 power, all depending on the height of the turbine. So the higher the turbine is, the more power it produces. We're just going to plonk it down at ground level just for an example today. Again, there's one output similar to the solar panel, and when you plug it in, you'll notice that even with the light on, the timer is still going up on the battery. This is because we're charging the battery faster than we can use the power coming from it. Now let's get back to linking these together. To do this, you do need something called a root combiner. It's a purple reddish block, and when you place it down, you'll see 3 points that you can connect to. It's as simple as 2 inputs in the bottom, so the solar panel will go into one and the turbine will go into the other, and then out of the top will be the combined power from both that you can put straight into your battery and charge it even faster. You can see now there's 98 power going into the battery. So because we've got more power than we can use, we can start adding more stuff. So let's stick a few more lights up. We don't need a separate circuit for these because there's something called a pass-through on these lights. Like most components, there's a pass-through on them. I will explain this now. All you have to do is use the pass-through of an active light and put this into the input of the next light. You can then use the pass-through of that light and put it into the input of the next one, and so on and so on. And when you flick the switch, all will turn on. When we look at the power, you will see the usage is now 7 out of 10. This is because we've got 3 lights using 2 power each and a switch using 1 power. Quick maths, that's 7, which means we've got 3 power left. Now let's try and add an auto turret and see what happens. The auto turret will use 10 power, but the battery outputs a maximum of 10. Let's connect it up, pass the switch, and we'll see what happens to the circuit. Now as you can see, it doesn't work and the circuit is dead. This is because the switch is using 1 power and the turret is trying to use 10, which is 1 more than the small battery can handle, so it'll turn the turret off. You can see if you hover over the turret, there's only 9 electricity flowing into it, obviously 1 less than what's needed. This is a sign you need to start upgrading. The smaller battery can only just power a turret if you connect it directly to it. So let's not bother with a medium battery, let's just go straight to large. Although it takes up more space, it works exactly the same way. We can put power in to charge it, and we can draw power from it into our circuits. The large battery can power a planet if you need it to. It outputs 100 power, which should be enough for any base. For this example, I'm going to connect it to a light and even wire up the turret through the light pass through. So you can see it's using 17 power, way under the 100 limit that we're allowed. So let's keep going and add more stuff, and let's see what we can get out of it. Even though there's only 1 output from the battery, it's still possible to have multiple circuits running from it. One way is by using a splitter. Branches are a little bit better than a splitter, but I'll get into that in a minute. To use a splitter, put the main power into the top of it, and then it will evenly convert the power 3 ways from the bottom. For example, the large battery outputs 100, the splitter uses 1, which means you've got 99 power left split between 3 outputs. 99 divided by 3 for the 3 outputs is 33. So you'll have 33 out of each output. I can't really put it any more simple than that. Remember, for the example on the screen, the switch will also use 1 power too. So what if you want more than just 3 circuits? Well, you can just keep adding splitters, but remember, wired up this way, you'll have less and less power every time you add a splitter, and it gets to the point you're wasting usable power too. So the best alternative is to use a branch. They're little black bricks, similar to the root combiners as I showed you earlier. The power goes into the bottom, but this time you have 2 outputs. The reason these are better is the fact you can use every drop of power by configuring the amount of power it outputs through the branch out. Let me show you. There's 3 lights using a maximum of 6 power, so I will configure the branch to only output 6. The rest of the electricity will continue to flow through the branch so you can use it elsewhere, which in this case is 92. The sum for this is battery outputs 100, switch and branches uses 1 power each, plus 6 from the branch gives you a total of 8. That means you have 92 power left. Again, simple. You can connect to another branch. The turret uses 10 power, so I'm going to branch 10 power out of this and connect it to the turret. This means you've got 81 power left. 92 minus the 10 for the turret, minus the 1 for the extra branch we've just used, and that means we've got 81 left. So now I've shown you how to use every ounce of electricity you've got. Let's move on and you can apply it into your own circuits. Now we're going to cover a slightly more advanced component. This is the HBHF sensor. Now this only uses 1 power, which makes it an absolute bargain to use. It's basically a house alarm. It'll sense anyone in a room and output 1 power when it does within a 10-meter radius. You can set it to ignore people authorized or only set off on people that are authorized or activate. With everyone, it's up to you, and it all depends on what circuit you're using. This makes it quite a useful tool. Simply place it where it has a clear view of a high footfall area, or simply place it in a room that you want to protect. I'm just going to stick it on a wall here, and you can see it as a power in and a power out section. For this, I'm going to bring in a smart switch and talk you through it the best I can, and we're going to cover 2 components at the same time. The AND switch will only output power if both inputs receive power. If only one side has power, then it will block the pass through altogether. Let me show you why this is important. Remember, the HBHF sensor only outputs 1 power, and 1 power isn't really enough to activate most components, so we need the AND switch to feed more than just the 1 power so we can trigger more alarms. So the HBHF sensor goes in one side. I'm just going to use a splitter here just to make it easier. Make sure the HBHF sensor has power and set to include or exclude authorized depending what you want. I'm going to set it up to power these lights, which means I'll need a minimum of 6 power coming through. You can see there's power going through one side, that's the side that's lit up green, but nothing going through the other side as indicated with a red light. This means it won't let any power through whatsoever. You then need to put permanent power into the second slot. This means when the alarm picks something up, it'll let the highest amount of power through the AND switch, and in this case power the lights. When you walk out of range of the lights, the sensor stops picking you up, it cuts off its power output, and because there's no longer 2 streams of power going into the AND switch, it will turn off altogether. When you walk within range again, it'll turn back on, and so on. And there you go, you've just learned how to operate 2 complicated components in one go. So now let's move on to automating doors. So the first question is it possible? Well, yes it is. For this, all you need is a door controller. Again, it uses 1 power, it also has a pass-through, and all you need to do is place it on the wall next to the door, make sure the door is unlocked, and then simply pair the door controller to the door. You'll see a little green light on the controller, which means it's paired correctly, and then all you have to do is make sure you lock the door again afterwards. Then put power to the door controller and it'll simply open the door. When you disconnect the power, it'll close again. Now, because the door controller only needs 1 power and the HBHF sensor outputs 1 power, you won't need any fancy switches to power it if you're using both of these in kilter. Simply put the out of the HBHF sensor directly into the input of the door controller and the job's a good one. When in range, the door controller will automatically open. Just remember to exclude people not authorized for obvious reasons, unless you've got a trap bay set up, in which case knock yourself out. If you do want to add some more stuff to the controller, like automatic lights turning on or an alarm system like we've mentioned before, just simply set up an AND switch again, same as what we did previous. All you have to do is wire it up in the exact same way as we did a minute ago. The HBHF sensor in the bottom, followed by permanent power into the bottom. Then the power out of the top goes into the door controller, and then you can use the pass-through of the door controller into the lights or your alarms or whatever you want to power. So what if you're lazy and you don't like wires and you just want everything just one? Well, why don't you try automating your circuits? Strap in and let me show you how. There's a few things you can use: a receiver to receive wireless signals, a pager that goes in your pocket and beeps or vibrates when something outputs a signal that matches your pager, a broadcaster that outputs a wireless signal when activated, and a transmitter, which is a handheld switch and has unlimited range, so you can output any signal you want, all of which you can set to whichever signal suits you. So let's make a start by placing them all down. We're going to set all of them to 1, 2, 3 for now. I would recommend choosing a frequency harder to guess. So now all of these are set to 1, 2, 3. They will all talk to each other when active. You can see I'm pressing the transmitter and it's setting off my pager. When I put power into the broadcaster, it'll permanently output the 1, 2, 3 signal, and when we put power into the antenna and out into the door controller, it will open the door when the 1, 2, 3 signal is sent out. Because I have the power going into the broadcaster as well, this is outputting the signal to the antenna next to it and keeping the door open. If you want the door to stay open temporarily and then close again, simply don't attach the wires to the broadcaster through the pass-through of the door controller. Now, as you can see here, we don't have much control, and the only real way to break the signal and close the door is to break the power. There's a million ways we can do this, but if we dig too far into automated components, then the video would last forever. All I'm doing in this video is making you aware they exist and giving you the basic function. There is videos up in the cards now that will show you most components. If there is anything you want me to cover, let me know in the comments and I'll make a video and get straight to it. What if you want to add bells and whistles? Well, you can get blue flashing lights, red siren lights and audible speakers too, that all activate when power is inputted into them. The siren light and blue flashing lights both have pass-throughs. At this moment in time, the speaker doesn't, so if you are linking them all together, make sure you put the speaker last. And again, just for ease and to save time, I'm going to use a splitter to put the power in and show you what they all look like. This brings us to our next component, the pressure switch. You simply place these on the floor and they use 1 power. Interestingly, they do output 1 power for a very short time without anything connected. This is good for calling elevators, for example. You can see here it's powerful enough to power the blue flashing light momentarily. I'm going to connect it up fully for you here. It's pretty simple. It has power in on one side and the pass-through on the other, and when you step on the pad it will activate the components connected to it. You might notice that if you step off the pad the alarms instantly go off. Well, what if you want to keep them on, especially for a set amount of time? Well, this brings us to our last component of the video, the timer switch. You can set the timer switches to activate for almost an infinite amount of time. All you need to do is plonk it down, make sure the power out from the pressure pad goes into the side. This will automatically trigger the switch. Make sure the switch has power in the bottom. Again, a branch would be better. You can choose the amount of time the switch stays active for at this stage if you want to. I'm only going to choose a few seconds for speed and ease of showing you how it works. And then the power out from the top would go to whatever you want power in when the pressure pad is activated. Then when you press the pad, the alarms will stay on for the time you set it to and automatically turn back off until it's activated again. These are quite easy to spot, and if you are using these for traps, it is possible to cover them up with a rug or something similar. It won't affect the operation of the switch at all in your setup. Just be careful about the wires. You could put everything closer to the wall to hide the wires on the floor so they're not stuck out like you can see here. Now, I think I've banged on enough. I hope this video is better than the last one and a little bit easier to understand. If you've watched it this far, let me know you're a legend in the comments down below. Remember, you can find me on Twitter, Instagram and Facebook if you want to keep tabs on me and see what I'm up to. Really appreciate all of your support, and as always, I'll see you in the next video.